Hi, so this session is on solving inequations. So they are equations, but instead of an equal sign, we see an inequality symbol. So I'll just explain what I mean by that. So if you remember, inequalities are these symbols here. We have the less than or equal to, greater than or equal to. And so an inequation has one of these instead of an equal sign. For example, if I had 2x equals 1, just say, that's an equation because we have an equal sign. If we have 2x, just say, is greater than 1, this now is an inequation because instead of an equal sign, we have the greater than sign. And with inequalities, we actually solve them the exact same way we would solve an equation. For example, if I had to solve this, I've got 2 times x, so I'll divide by 2 and divide by 2. That cancels out. So x would be a half. That's how we would solve this equation here. To solve this inequation, we do the exact same thing. Divide by 2, cancels out, divide by 2. But instead of x equaling a half, we end up with this. And it says x is greater than, if you remember that the larger gap is facing towards the x, x is greater than a half. So instead of x just being one number, in this case a half, like up here, x equals a half or 0.5 and nothing else. Whereas with this answer down here, x can be anything greater than a half. It can't be half, but anything above, like 1 or 1.5 or 10. And the solutions are endless, so there's more than one answer. Now before we start solving inequations, there's one thing that you need to remember. And to understand what I'm going to tell you in a second is we have to conduct some tests. Now, so I've set up test 1, test 2, test 3. And now with test 1, you notice that I've got 4 is greater than 2. Okay, is that true? Yes, it is. 4 is a greater number than 2. Now, if I decided to maybe, let's see, add 1 to both sides, so add 1 to that 4 there and to that 2, so I'm doing the same thing to one side and the other. Well, 4 plus 1 is 5, keep the greater than sign, and 2 plus 1 is 3. Now, does this still hold true? Is 5 greater than 3? Well, yes, it is. So that's okay. Adding 1 to either side hasn't changed. It's changed our values, but it still holds true. All right, test 2. Well, what if we take away 1? Let's take away 1 on both sides. 4 take away 1 is 3. Keep the greater than sign, and 2 take away 1 is 1. Is this still true? Well, 3 is greater than 1. Yes, that's true. So that still holds true. All right, let's try test 3. Let's multiply now. Multiply by 2 on both sides. And let's see if it holds true. Well, 4 times 2 is 8. Is greater than 2 times 2 is 4. Is 8 greater than 4? Yes, it is. So that still holds true. So with these 3 tests, we have added, subtracted, and then multiplied by a positive number. And they have all remained true. Let's do a couple of more tests. Now our last operation that we haven't tried is dividing. So let's try dividing by 2. So if we divide 4 by 2 and divide the 2 by 2, well, 4 divided by 2 on this side gives us 2 is greater than 2 divided by 2 on this side is 1. Is 2 greater than 1? Yes, it is. So it holds true. So far we have added, subtracted numbers. We have also multiplied and divided by positive numbers. So what's left is to now, let's see what happens when we multiply by a negative number. All right, let's times this side by negative 2 and times this side by negative 2. And let's see what we get. Well, 4 times minus 2 is minus 8. Keep the greater than sign. And 2 times negative 2 is negative 4. Okay, now, is negative 8 greater than negative 4? Well, actually it's not, because negative 8 is more down the negative end. Negative 4 is closer to the positive end. So this is now suddenly false. And if you can't see this with negative numbers, look at a number line or do your own test where you have negative values. Okay, so far multiplying by a negative number is false. Let's try dividing by a negative number and see what we get. So if I divide, so test 6, if I divide 4 by negative 2, and if I divide 2 by negative 2, let's see what we get. 4 divided by negative 2 is negative 2, greater than 2 divided by negative 2 is negative 1. Now, is this true or false? Is negative 2 greater than negative 1? No, it's not. So this is actually false. So what has happened is, when we multiply by a negative value or divided by a negative value, the expression here, or with the inequality sign, has become false. So remember, when we multiply by a negative value or divided by a negative value, and we have to keep this in mind when solving inequations. And basically, the whole idea is, if we multiply or we divide by a negative value, we have to switch this inequality sign to make it true. So for me to make this statement true here, I would have to go negative 8, switch this, is less than negative 4, which is true. To make this one true, I would have to switch it. So negative 2 is less than negative 1. By switching the inequality sign, I have made these statements true. And we have to do that when solving inequations. We have to switch the sign only when we divide or multiply by a negative value. So write that down. So write this point down, and that is, when solving inequations, you need to switch the inequality sign when multiplying or dividing by a negative value. Okay? And that's basically it. So you solve it as you would normally. Just when you divide or multiply by a negative value, you must switch the sign. So let's do a few examples to understand how to do this. So let's try a few questions now. And so just remember that whenever you divide or multiply by a negative value, you have to switch the sign, and that's it. So let's start with the first one. So if this is still confusing you, remember, it's the same as having this when it comes to solving and working out. X plus 2 equals 4. If you can solve this, you do the exact same thing as you would do here. If that's a plus 2, we have to minus 2 on both sides. So let's do that. So minus 2 on this side, minus 2 on that side, because we need to solve for x. That cancels out. Now, see how we got a negative 2? Did we multiply a negative 2 or divide it? No, we just subtracted. So this sign does not switch. So x will be greater than or equal to negative 2. And that means x can be negative 2, it can be negative 1, 0, 1, 2, 3, 4. Anything greater than negative 2 or equal to. So 2. We have 2 plus x is less than 6. So once again, we have to get x on its own. That is a positive 2, so we have to minus 2 on this side. That cancels out. Minus 2 on that side. So x will be less than 6 minus 2 is just 3. We didn't switch it because we only subtracted. All right, question 3. Now, I can see that with question 3, we will be switching the inequality sign. If you notice this negative here, how it's next to the x, so it's saying negative x. So whenever you see that, it's a hint that you'll have to swap this sign. So keep that in mind. Now, to solve for x, we need to get 3 on its, get rid of the 3. That's a positive 3. Okay, we know this negative belongs to the x. So the opposite of plus 3 is to minus 3 on this side, minus 3 on that side. This cancels out, and we're left with negative x is still there, is less than or equal to 5 take away 3 is 2. Now, have we finished? No, we haven't. You notice this negative that's sitting here? It has to be put on this side. And remember that trick I showed you in the earlier session? If there's a negative on this side, all you have to do is bring it to this side here. But to do that, what we're actually doing is, that negative, we know it's really a negative 1. And to get rid of it, we know we're saying minus 1 times the x, and the opposite of times is to divide by negative 1. And divide this side by negative 1. And what you've noticed is we have divided by a negative value. Yes, this cancels out, but we must also switch the inequality sign because we divided by a negative value. So we're left with x is, now instead of less than or greater than, let's switch it, and we end up with, so instead of less than or equal to, we switch it and we end up with greater than or equal to, and 2 divided by -1 is just -2. And that will be your answer. Okay, so it's very important that with this one here, that if you only see a negative, it's really -1, and so we're dividing by -1. Or if you did it the shortcut way and just brought the negative over, that's fine, but make sure you switch this, because by bringing a negative over here, you have divided by -1. Okay, let's try the next. Okay, let's try the next 3 examples. If you want to pause it and do it yourself, then try it. So with 4, x is pretty much by itself, but you notice we have this negative here. And like the previous example, if we want to bring the negative to this side, we are actually dividing by a -1, okay? And divide by -1. And because we have done that, we must switch this inequality sign. So our answer will be x is now less than or equal to 3 divided by -1 is -3. And that would be our final answer. And we switched the sign because we divided by a negative value. Down here with 5, now if you remember that trick I showed you on the other session, and that is if you have a negative on this side and a negative on that side, you can just cross them off. Now if you did that, that's fine, but you also have to switch this sign, because by crossing them off, what you've actually done is, once again, divided by a -1. Divided by a -1. That cancels out, and a negative and a negative would make a positive. That's why you must make sure for this one, you switch the inequality sign. It's now x is greater than or equal to, and we end up with a +4. Okay, so just be careful when if you do cross off the negatives, just remember to switch the inequality sign, okay, because we're actually dividing by a -1. Now with number 6, I can see here we won't be switching the sign because there's no negative next to the x. So to solve this, we've got 2 times x, so we just divide by 2, divide by 2. No need to swap because 2 was positive, so x is greater than 3. Nice and easy. Okay, let's do the next few examples. So with 7, you notice we have now -2 times x, or -2x, is greater than 6. So we can see 2 is a negative value being multiplied with dx. So we divide by the -2, and that means we divide this by the -2 as well. Sorry, it's just frozen. There we go. Divide by -2. And this cancels out, but because we divided by a negative value, we must switch the inequality sign. So I'll just put the answer over here. So x will now be less than 6 divided by -2 is -3. And that will be the answer for 7. So just remember, we had to switch it. This one down here, we have x divided by a +6. We can see there's no negatives near the x, so we won't have to switch this sign. So if we're dividing by 6, the opposite is to times by 6 and times by 6. So this will cancel out. So we're left with, I'll do the answer here, x will be less than 3 times 6 is 18. We didn't have to switch the sign because 6 was positive. But let's look at 9. You notice 9 is pretty much the same as question 8, but what do you notice sitting over here? It's a negative. And see how the negative is sitting in the middle? Okay, it's saying this whole thing here, this whole number, is a negative. We don't actually know what the number is because we don't know what x is. But this negative, you can say it belongs to the x or it belongs to the 6, or it can just sit in the middle. So for this example, what I can do is I can write the negative next to the 6. Because we have one negative, the whole thing is still negative. And the reason why I've done that is, well, if we're dividing by a -6, the opposite is to multiply by a -6. And of course, we must do the same to this side. But because we multiplied by a negative value, what must happen? We must switch the inequality sign. So it will be greater than. So the 6's cancel out, or the -6, and we end up with x is now greater than 3 times -6 is -18. Okay, so you can see the difference between questions 8 and 9, and the difference this little negative over here made. We had to switch the inequality sign. Okay, now I forgot what number I was up to when I cleared the page, so I'm guessing I was up to 10. Hopefully I'm right. Now with question 10, you can see there are 2 steps involved to get x on its own. And what goes first? We know it's this -2 or -2 here because it's the furthest away from the x. So what we're going to do is opposite of -2 is to +2. That cancels out and we must +2 on this side. We do not switch a sign because we added 2. So x divided by 6 is greater than or equal to 5 plus 2 is 7. And our final step is to now multiply the 6, so it cancels out, times 6. So finally our solution will be x is greater than or equal to 7 times 6 is 42. Okay, and we didn't have to swap the inequality sign or switch it because there was no negatives we multiplied or divided with. This one down here, now I can see this one down here, we will be switching the sign because you know this is -2 here, it's attached to the x. So we might have to divide later on by -2. Keep that in mind. But our first tip is to get rid of this -9. So we +9 on this side, +9 on that side. So we end up with -2x is less than 7 plus 9 is 16. And then our final step is to now divide by -2. And because we're dividing by -2, we must switch the inequality sign. So that's why I circle it. The -2 cancels out. So just down here, we'll put our answer. X, switch this, is greater than 16 divided by -2 is -8. And that will be the answer or solution for question 11. So let's try a couple more questions. So we have -5 times x and -5 times 7. So we know that with this one we have to remove the brackets first. So -5 times x, that's just -5x. You can do it this way, there's a plus there, so put a plus. And -5 times 7 is -35. It's greater than or equal to 10. Now we know that a positive and a negative sitting together makes a negative. So we end up with -5x minus 35 is greater than or equal to 10. Okay? Now if you wanted to do -5 times +7 mentally, that's fine as well. Now our next step is to get rid of the -35. And then we have to get rid of the -5 later on. So opposite of -35 is to +35. That cancels out to 0. And we have 10 plus 35. So we end up with -5x is greater than or equal to 10 plus 35 is 45. And our final step is to divide by -5 and divide by -5. This cancels out. And before you forget, make sure we switch this because we divided by a negative value. So x will be now less than or equal to 45 divided by -5 will be -9. And there's our final answer. So our final question for this session is this one here. And I've picked one where we have x on both sides. So our first step is, well, let's get rid of this bracket here. So let's expand the bracket. 2 times x and 2 times 3. So we have 12 minus x is greater than, sorry, a bit crooked, 2x plus 6. So we've expanded the brackets. Now, we need to bring the x's together. And it is just like normally if we had an equal sign there. It is your choice to what you want to do. You can bring the negative x to this side here, or you can bring the 2x to that side on the other side. I'll bring the 2x to this side here. Because I have an inequality sign, you have to be careful if you want to rewrite it later on. And I'll show you what I mean in a second. So we have 2x here, and we're going to bring it to this side so the x's can be together. So we, instead of positive 2x, we have to minus 2x. That cancels out, and we have minus 2x on this side. So we have 12 minus x minus 2x is greater than a positive 6, or just 6. Minus x minus 2x, this cancels out to be negative 3x. So we now have 12 minus 3x is greater than 6. Our next step now is to get x on its own. And we have a 12 and a negative 3. So this 12 is to go first. We can see it's the furthest away. So the opposite of plus 12 is to minus 12 on this side, minus 12 on that side. So we have minus 3x is greater than 6 minus 12 is -6. Now, our final step is to divide by -3. Divide by -3 and divide by -3. But please make sure you get this inequality sign and you switch it. So cancel out the 3. So I'll do our final answer over here. We have x will be switch this less than -6 divided by -3. Two negatives make a positive. So we end up with 2. So x is less than 2. So just make sure you switch this inequality sign when dividing or multiplying by a negative value. Now, the last thing I wanted to show you was if we had, for example, something like this. 2, you say we had this greater than and an x. And just say you wanted to bring the x to this side. Now, if you remember in the first session, if we had 2 equals x, okay, just comparing these two, we could easily rewrite this one like this. We could say, well, just write x equals 2. These two things here are or equations are showing the exact same thing, okay? 2 equals x, 2 equals x. Now, if we were to do this for this one, you need to be very careful, and I'll show you what I mean. I'll just write this out so I have some more room. Now, see how we have, if we read it from left to right, we have 2 is greater than x, or we have x is less than 2. Either way you read it, it's still true. So now, if you wanted to rewrite this, if you did this, x, if you wrote x, if you wrote the greater than symbol like this, and then 2, you have actually made a big mistake, and you have changed this expression here. Instead of saying x is less than 2, you are now saying x is what? Greater than 2. So you need to be very, very careful. If you don't like working with x on this side here, and you want to switch it, you must be careful when you have inequalities. It is not as easy as when you have an equal sign. So the proper way to switch this was to actually have the inequality sign now turn into a less than sign. Because have a look, is the pointy part facing the x? Yes. Is the pointy part still facing the x here? Yes, it is. And the bigger part here is facing 2. Greater than part, bigger part is facing 2. So you can see how even though it looks different, we're saying this is instead of saying greater than, it's now less than, it's still saying the same thing in terms of what we have. So if I say 2 is greater than x here, am I saying the same thing on the bottom? 2 is greater than x? Yes, I am. Or if I'm saying x is less than 2, I'm also saying x is less than 2 down here. So this is extremely important, and a lot of students make this mistake, okay? So please be very careful. If you want to rewrite it where x is on this side, and you have one of these symbols, the inequalities, please make sure you switch this. And if you get stuck, just look, the pointy end faces the x. Pointy end is facing or pointing towards the x for this example. So let's just do one more example using what we've just learnt. Now, see how the x is on this side? And just say you don't like solving with x on this side and you want to rewrite it. Well, let's do that. X divided by -2. Okay, I'm going to put my 20 here. Now, this inequality sign, I must switch it because the greater than has to face a 20. And the pointy part, once again, is pointing, in this case, towards the x divided by -2. So let's switch it. And we end up with the same thing. We're saying 20 is greater than this. 20 is greater than that, okay? And now to solve this, we have to divide, we're dividing by a negative value, so we have to times by a -2 and times by a -2. This will cancel out, but because we multiply by a -2, we need to switch this inequality sign and make it face this way, so greater than or equal to. So we have x is greater than or equal to 20 times -2 is -40. Okay, so please be careful. If you don't mind working with x on this side, you could have just solved this by saying yep, times by -2 cancels out and then switching it. But just keep in mind, if I have this answer or if I have -40, okay, less than or equal to, less than or equal to x, these two expressions here are saying the exact same thing. Yes, they look quite different because we can see this is greater than, this is less than. But because the x is on this side, it's saying the exact same thing. Okay, thank you.